Hello, today I'm going to talk about two-dimensional arrays in Visual Basic. Tables or arrays that require the two indexes, row and columns, to identify particular element are called two-dimensional arrays. To identify a particular table element, we must specify two indexes. The first, by convention, identifies the element's row, and the second, by convention, identifies the element column. The general format to declare a two-dimensional array is you first of all write dim as a keyword, then array name, then in the bracket you write sub1, sub2. So this means that we have two indexes. We have sub1 as rows, sub2 as columns. Then you mention the data type. It means the type of items this array will hold. You can say as data type. So here we have an example. Dim matrix A 3, 4 in bracket. So this is an array called matrix A having 3 rows and 4 columns. So here 3 represent rows and 4 represent columns. You know, matrix is a good example of two-dimensional array. Now let's see an example here. So this example says, write a VB program which allows to enter element of matrix A and element of matrix B, and then print the addition. It means the user is supposed to enter the element of matrix A and the element of matrix B, and then after, the program shows to the user the addition. Now let's see how to work with Visual Basic, how to find this the addition of these two matrices. So let me open Visual Basic. I click standard X, open. Now let me prepare the working environment. Yes, so this is Visual Basic form. You can enlarge this form. Now in this form, on this form I need to 3 areas where matrices will be displaying their items. First, I need to draw where items of this matrix will be displayed. So let me use a control called picture box. It is here. I can click picture box. Let me draw it here. So this is where the element of first matrix, let me call it matrix A, will be displayed. So let me also bring a label which will identify the element of this matrix. Let me call it matrix A. Let me bring another picture box for second matrix B. So let me bring its label, the label which will identify this matrix. I can write matrix B. Let me bring another picture box for matrix C, which will be the result of this addition of 2 matrices. Let me also label it here. So this is matrix C. So let me change the font size of these labels. I can change the font size. So let me set 17 as the font size of these labels. So let me change also the font color, bar color of this matrix, the bar color of this picture box, which is in the place of matrix A. Let me change its bar color. I can click here. Let me change the bar color of matrix B. Let me change the color of matrix C. Okay, good. Now I can also change the font size of the content of this picture box. I can click it and then I go to font. Let me also change the font size of this picture box, the second picture box. This one also. Okay, now what is next? The next thing we need here, we need to think about variables that will be declaring this program. So we need actually variables to be used here. So I can first of all bring the button that will be appearing on this form. It means there's a button that the user will click so that the program starts. Let me bring this button. Let me just put it here. I can put it here. I can call this caption value of this button input element, or I can say input element of matrices. So let me change its font size. So this is where the user will click before the program starts, so that he or she starts inputting element of these matrices. Now let me bring another label here showing the operation which will be done here. This is a label which will show the operations that will be occurring here. So let me call it plus. Let me put the plus here, but let me align it in the center. Let me also think about because after adding these two matrices, the user will click a command button so that he may see the result. I can say let me bring a command button that will play this role. I can change its caption value as equal sign. So let me change its font size. So normally this is the command button that the user will click so that element added in this matrix A and matrix B will be added and input here or displayed in this matrix C. Now in this program, I need some variables to be working on this button and this button. So these variables will be declared as general sections. So yeah, they can be used in both two buttons, this one and this one. So these kind of variables should be declared in the general section. So to declare these variables, I double click the form and I go above here. So this is called general sections or declaration section. So this way I'm going to declare these variables. I can say now dim I j, and also I need to declare these matrices. So matrix A will hold. So let me say this matrix will hold element in the 3 rows and 3 columns. So 3 here is the number of columns, and 3 here is the number of columns. This one is for rows, this one is for columns. Now I can also set another matrix B. It is a matrix of the second matrix. It is also a matrix of 3 rows and 3 columns. I also need the third matrix, which will be the additions. So this one will also have 3 rows and 3 columns. Now all these variables will be set as integers. Now they are in a section A or in a general section or declaration sections. Now we are going to program the buttons, right? Let's program the buttons, these buttons. Okay, let me close this form. Let me also bring the project explorer up here to work with it. Now I'm going to program this button because this is where the user will click so that the program start supplying element in this matrix A, matrix B. Let me double click it. Now here I have command 1. So the name of this command button here, it is command 1 as it is mentioned here in the property windows. So let me double click it. Now when you double click this command button, it will redirect you in the window code where you can write code. Now here I need to start now thinking how these matrices will be supplied. I can say now I can start now using loops. I can say for I equals 0 to 2, because as I is in the place of 4 rows, so it will start from 0 to 2. Now another loop, the inner loop has j. Okay, now I can say here for I equals to 0 and for j equals to 0, I can now start inputting the first value into the matrix A at position I and j. I can say A bracket, I can say A I j, so then put in the small letters, I j equals, let me use input box, input box bracket. I can say here enter element of matrix A. This is the message that the user will see enter element of matrix A. So let me put double quotes here. Okay, so this is the first message that the user will see after clicking that button. Enter element of matrix A. Now after enter, okay, this loop will try to allow him or her to display this message, and the user will input. Now after inputting that value at position I and position J, now what will happen? That value will be displayed here in this matrix. So I can say now picture 1, because the name of that picture, that box where the value will be displayed is called picture 1. Picture 1 dot print. So I write the array name. This is ij. So I put semicolon space. Let me set a space of 4. Okay, now it means at position I and J the user input a value, and this value will be printed in the picture 1 here. Okay, now let me close the loop. Let me show that after doing this, after executing this instruction, then the compiler will execute the new value of J. And after all of this, after reaching to the final value of J, automatically the compiler will be outside the loop which contains J. Then being outside, it will reach, okay, let me put here semicolon. It will reach to the new state, to the new instructions, which says print, picture 1 dot print. Now here I cannot put semicolon because I want every time that when the compiler reaches here, automatically it goes to the new line. So when you put semicolon, everything will be on a horizontal line. So now here I can show that after printing the empty space without continuing on the same line as this value, so the compiler will go to the next value of I, and this is it shows next I shows that compiler goes to the new value of I, or the new value of I will be calculated. Now what will happen here after this? So this is the end of this loop which contains I. Now I'm going to show you how to actually from here up to here, it's just to supply the element to the matrix A. Now let's see how to supply element to the matrix B. I can copy this block. I can copy it and paste it here. Now let me change the name of this matrix. It is B now. This is B. And also let me change it here. Okay, now. Okay. Okay, now let us now run this program and see how this element will be supplied into these two matrices, because I have not yet started entering them, and then I suppose to add this element of these two matrices into the third matrix. So before I add them, before I write code for adding them, let me first of all see how they are supplied. I can now run the program. Now here the user will click this button, input element of matrices. So the user will see this input box. So let me start entering it. Now I have reached the second row. Now you see, when you reach to the second row, automatically the program will ask you to enter the element of matrix B, because this is one block, this is another block. I can now start entering the element of the matrix B here. Oh, there is a problem here, because all these elements should not be entered in the same picture box. Maybe the name is the same. Let me change the name here. There is also a problem. So I think the mistake is here. So this is not a picture 1, but it is picture 2. That's why the mistake is even here. Yes, even here. Yes. So let me now run again and see how it's gonna work. Now I can click here. Now I start entering the element. Now you see, when you reach at the last row of this matrix, automatically this block will be skipped. We start this block here, right? This is for the second matrix, the second picture box. We can now start from here. Now it's asking me enter elements of matrix B. I can enter them. Yes. Now you see the element have been started just appearing here. Now it's done. You see, these two matrices now are being supplied. They are getting element from the users. Now we are going to see how to add them here. How you can add them. How you can add these two matrices. So I've said that matrices or matrix, they are good examples of two-dimensional array. So you see, it is two-dimensional array because this matrix has rows and it has columns. So this is two-dimensional array. Normally a two-dimensional array has rows and columns. Now let's see how to add these two matrices in the third box. Okay, in the third picture box, I close this one. Now I want just to program this button. This is where the user will click so that element entered here will be added here, right? So let me double click it and enter in the window code. I'll call the window. So now I'm here down. This command 2, as it's mentioned here, its name here, it's command 2, as you're seeing. That's command 2. Now let me double click it. Automatically the program redirects me here. Now in this block, I will use some variables that have declared above here, right? But as I wanted to find the result or the addition of two matrices, remember I will add rows and columns. Rows are added to rows, columns are added to columns. Now let me declare, okay, I have already declared the matrices here. Okay, so what I have to do here is just to add them as usual. I can say now, so that command button will be clicked, and what will happen to that third picture box. I can say for I equals to 0, I will start from 0 to 2, because starting from 0 to 2 we are having 3 rows. Now for j, we also start from 0 to 2. Now what will happen? I will say the matrix C at this position of matrix C, at index I, at row I and j and column j, there will be addition of element of matrix A at I position and j position. It means at row I and j and column j, I will add them. I write B here. You can have I, j. I'm adding two matrices. A and B will be added, and the new value will be stored in the matrix C at I and j position. So let me now close the... But here I also have to show how the value will be printed in the picture box. I can say picture 1, that's picture 3. Picture 3 dot print. So normally I will print that value of full matrix C, which will be locating at I and j position. Now let me close. Let me show the end of inner loop. Next j, it means after performing this instruction, automatically the compiler will go to the next j. It will continue up to this value. Then after finishing or after reaching the final value of j, automatically the compiler will go outside of this loop. So if it goes outside of that loop, it will meet a new instruction saying picture 3 dot print. So this will print nothing. Remember here I have to put space. I have to put this element every time when an element is printed in columns horizontally, semicolon will be there. So this semicolon is here for allowing element to be printed horizontally. It's the opposite of end line in C++. I can now add space. So let me set a space of 4 spaces. Now this one will not have a semicolon. If it has semicolon, the element will be always on the same line horizontally. So to allow the new element to be on the next line automatically, this one will not have a semicolon. It's as if it will reach the empty space, automatically it goes to the new row. Now let me close. Let me show that after these instructions, the compiler will go to the next value of full I. Now this is how it will be done. It means this matrix C will take the addition of matrix A and B as they have been supplied above here. Let me now run and see how the program will look like. Yes, the program is here. Yes, you can say now. So the user will first of all click here to supply the matrix. Let me enter this element of the matrix. So reaching the third row, automatically the program will ask the user to enter the element of matrix B, because we are reaching just here. Okay, we have reached to the last value of I, which is the row, the third row. Automatically we enter in this section where we are supplying element to the matrix B. So let me start supplying it. So as you're seeing, elements are being entered in this box. So after that, it means I have reached here. I've reached to the last row, which means when I reaches to the final value, which is 2, automatically the program will this program asking to input element in the matrices will stop. Now when the user clicks here, we know matrix A has this element, matrix B has this element. Now what will happen if the user clicks this button? Let's see if it is going to supply the sum of two matrices to then the third matrix. Let's see, as it is being mentioned here. Let's see. Wow, that's correct, but there is a problem here. 49, there is a problem. The problem is just here. Okay, you know, when you are adding values from input box, the Visual Basic takes these values as text, so they have been concatenated here as text. So let me convert these values into numeric value. So the problem was here. So let me just convert this value into numeric value. I use var, which is a Visual Basic built-in function which convert text value into numeric value. Val here, even here, right? Okay, now let me start again. Okay, let's see. So I click on input element of matrices. I start inputting. So the problem was just here. The problem was here. When you input any value through input box, Visual Basic takes that value as a text, not as a numeric value. So when you're adding, you have to remember to convert the values into numeric value. So let me continue inputting these values. Okay, now when I reach to the third row of this matrix, automatically I will start this block. Okay, it means I has reached the last row. Okay, the last row. So we automatically skipped and we start this block where we are required to enter element of matrix B. So let me start entering it. So this element are being entered here. Okay, great. Now let's see. When the user clicks this command button, what will happen? It means we are going to see if this block of instructions is working well. So let's click this button. Okay, I think it's okay. Let's see. 4, we are adding now rows. You know, when you add two matrices, you add rows. So 4 plus 7, we have 11. 8 plus 9, we have 17. 9 plus 3, 12. Now let's go here. 7 plus 4, 11. 4 plus 7, 11. 5 plus 6, 11. 6 plus 8, 14, 8 plus 8, 16, 2 plus 5, 7. So this is how you can add two matrices. So matrices are good examples of two-dimensional arrays. So this program just explain how you can add these matrices as you are seeing here, right? So now we can go to the next examples where we have a program, a Visual Basic program which reads element of a matrix of 4 rows and 5 columns. So this program adds the first row and the last row and then print the result as a new matrix of 1 row and 5 columns. So the user will input element of matrix. We'll have one matrix of 4 rows and 5 columns. So this program will add them, the first row and the last row of that matrix. Then the result will be a new matrix. But this matrix, let's say it is a matrix of 1 row and 5 columns. Because if you're adding the first row and the last row of that matrix, automatically you have a matrix of 1 row and 5 columns. Another way, it is one-dimensional array of 1 row and 5 columns. Remember, a one-dimensional array is an array of 1 row and n columns. Let's see how to do it. Let me continue with the Visual Basics. As I have one form here, let me add a new form. I click Project, Add Form. Then I click Form, Open. Okay, now let me prepare this environment where I will design this project. So let me bring a picture box. This is where the matrix will be entered. So let me bring a command bar, a label which identifies this section. So let me say this is matrix A. Let me change its font size. I can click here. Okay, so let me change its font color or font color. No, let me change bar color, the bar color of this picture box. Okay, and change it in this way. Now let me bring another picture box where the sum of first row and the last row will be added. So I can put it here. So let me label it. So this is, let me say, this is row 0 plus row, so that's row number, this is row number 3. Because remember, if the rows are 4, the first one is numbered by 0 and the third one, the last one will be numbered by 3. So I can change its font size. Okay, great. Now let me add buttons. So this button will allow the user to start entering the element of this matrix A. I can call it input. Okay, let me change its font size. Let me change the caption value of that command button. So let me say input element input element of matrix, input element of matrix. input element of matrix. So let me bring in another command which will allow to add the first row and the last row. So I can put it here. Let me change this caption as find, let me say find row 0 plus row 3. Let me change its font size. Yes, its font size. It means when the user clicks this command button, automatically the program will take the first row and it will add to the last row. The result will be displayed here as a one-dimensional array. Now let me set the variables. Now there are variables that I'm going to declare in the general sections, because variables will be used on this button and this button. So these variables which can be declared in the general sections, they can be used in more than one procedure, because here we have two buttons, so there will be more than one procedures. Now let me now program this button input element of matrix. I double click it, but before I program it, let me first of all set these general variables. I double click the form and I have to, okay, so let me go above here. Normally general variables or variables which can be declared in general section, they should be above here, right? So let me say dim, okay, let me say dim I j. Let me declare this variable I, dim I j, bracket. So this is a two-dimensional array of 4 rows and 5 columns. All these variables will be integers. Okay, now I can go now into this command button, to this procedure. I can say now for, because this one, remember, this is the command button that I have clicked, so its definition is here. I can say now for I equals to 0 to 3, because I represent the rows. Now for j equals to 0 to 4, j represent the columns. So what will happen? So the matrix A we receive a value from input box. So let me say, you can say enter element of matrix A, right? After entering element of matrix A, now this picture box will read them, or will be supplied, will print this element. Okay, I can say here now picture 1, that's the name of picture box there, picture 1 dot print then A, because it's going to print the value of that matrix at position I and j. Then it will print horizontally. That's why I have to put semicolon. the element in that picture box, the first row element will be printed horizontally. The reason why I have put this semicolon, I write space 4, I put semicolon. Now after doing this, I have now to end the loop by saying next j. I have to go to the new value of j. Then after, I write next I to show the end of this loop I, for I. So what is between next j and next I? I have to put picture 1 dot print. So why do I not put here semicolon? It means I want that after reaching to the final value of j, the compiler will start the new row. On the new row, the compiler will meet an empty space which has been printed. So this empty space, we allow to write that value without going on the same line like the values of the first row or the second row. Then here, okay, so after supplying of values in this matrix A, let's see how it is going to work. Okay, so let me first of all run this program, but before I run, remember I have two forms here, form 1 and form 2, right? So if I run, form 1 will be displayed, will be open. Now to set the startup object, as I have two forms, I want to start from form 2, so I have to change the startup object. I click project properties, then I click here, I choose form 2 and okay. Now if I run, the program will start from form 2 as the startup object. You see? Now let's run and see the result of this program. Now here we have input element of matrix. When the user clicks here, automatically the program will ask him or her to enter element of matrix A. So let me start entering them. So here there is a mistake here. There's a mistake. Why these elements are being printed vertically? I can see there's a mistake that I have to correct. Let's see what's wrong here. Oh, it is here, right? You see, this is a mistake. So j start from 0 to 5, not to 0. To 5, no, to 4, because we have j represent the number of columns, and yet we have 5 columns. So let me run again. I click input element of matrix. Okay, let me start running. Okay, so let me run. Okay, so let me just put this window here. Okay, so when I click here, the program will ask the user to input element of this matrix. So let me input them. You can continue inputting this element as they are here. C. Okay, so as you're seeing, we have the matrix of 4 rows and 5 columns. Now what is remaining? It is to see how you can add the first row and the last row. So the program is going to take the first row element and add it to the last row element. Let's see how to program it. So you are normally going to program this button. That's what is going to be done. Let's see now how to program it, because the user, after inputting element in this matrix, automatically she or he will also press this button to see the result of this operation. So let me also program this one. I double click it. Okay, now the command button 2 is down here. This is the procedure. That's the sub procedure called command to click. Let's see now its definition. Normally here we need to declare a new matrix, so which is one dimension matrix. Okay, because if the first row and the last row are added, so the element or their result will be stored in a one dimensional array. Let me call it, let me say dim m. So this matrix, let me say it's an array, or it's one dimensional array, which can be a matrix of 1 row and 5 columns. So this array, which is one dimensional array, we have 5 as its size. So this 5 means that the element will be stored in 5 boxes, 5 columns. Okay, so this is a matrix of 1 row and 5 columns. Now let me say this will be declared. Okay, this will hold also the integer variables. Okay, now I can say here, how can I add this element in this matrix? I can say for I, remember variables, these variables above here, they are declared as general variables, or they can be used in whole part of this form, in all procedures of this form. I can say for I equals to 0 to, okay, let me use j. Represent the columns, because columns will they want to be varying, not rows. Rows will be constant. So I can say now for j equals to 0 to 4. Remember, j represent columns. Now I can say now m, the matrix m, we receive the new value, or its value at position I and position j. Now what will happen? It will take the element in matrix A at row 0 and column j, because j will be changed, not rows. That's the column, because values will be added will be printed horizontally. And also it will take, because we are adding the values of first row and values of last row. Now it will take another value of matrix A at row 3. Remember, the last row of this matrix is 3, because the first one is 0. And j will always change. For I equals to 0, for j equals to 0, I will take a value at this position plus a value of this matrix at this position. I add these two values and I kept that value, the result, in matrix M at I and j position, then j goes to the new value. The compiler will automatically, after executing this instruction, the compiler will go to the next value of j. But let me say that after finding the value of j, so that picture box, the picture box here, this picture box will print out the result. Okay, I can say now here picture 2 dot print. It will print that value that has been entered in M at position I and j. So I can say this is I, this is j. So to print them horizontally, I have to put semicolon, because if you don't put semicolon, all values will be printed vertically. So this semicolon replaces end line. If you don't want it to end line, put semicolon, then put space. I can put now space of 4. Now let's see. Now what will happen here? So let's see, run the program and see how it will bring the result. I click run button. Now let me first of all supply the element of the matrix A. Okay, so I input the element. So I'm reaching on the third row. I also have to supply the 4th row. So as you are seeing now, we have a matrix of 5 columns and 4 rows. Now let's see, if the user clicks this button, what will happen? So the first row will be added to the last row. Let's see if it is the case. So there is a problem here, wrong number of dimension. So we can check it. Okay. So let's see. This is let's see. Oh, there is a mistake here. So the matrix M, the array M is not a 2-dimensional array, it is 1 dimension. So every time, it means here I can write now I can write J. Let me put J here, or let me put I. Yes, actually I can put the value of M will be a 1-dimensional array of, because J is represent the columns as it is mentioned here. I can write now 0. Okay, let's see how it is going to be done. So the error is just here. You see, this array is an array of 5. Okay, let's say 5 columns. So let me just remove this I, because J represent the number of columns, and here, okay, because this is 1-dimensional array, it's not 2-dimensional array. So this J represent represent the number of the size of this array. It's a number of columns. Okay, so every time, okay, j will start from 0 up to then it will end to 4. From 0, okay, from j equals to 0, then I will take a value that is on row 0, column j. I will add to the value in the same matrix, which is on row 3 on column j. Right, now let's run and see if it is working. Okay, let's now put our window here. Okay, so let's now supply the matrix here. Okay, I put now this one. I'm supplying the values to the matrix A. So this matrix A has four rows and 5 columns, as you're seeing. Okay, so we have four rows and 5 columns. Now what will happen if the user clicks this command button? Let's see. Okay, so we see that Visual Basic will print the result of addition of first row and last row. As you're seeing, we have 4 plus 6, it is 10. 5 plus 4, it is 9. 6 plus 7, it is 13. 7 plus 5, it is 12. 8 plus 8 is 16. So this is a one-dimensional array. It is an array of 1 row and 5 columns. 5 columns. So normally this is how you can solve this problem, where the user the program reads element of matrix of 4 rows and 5 columns. Then it adds the first row element and the last row element. The result is printed into a one-dimensional array, okay, which is an array of 1 row and 5 columns, as you are seeing here, right? So this is how it can be done, and it's normally not difficult, right? It's not difficult. So this is how you can solve this program. So thank you for watching, and remember to share these tutorials, and remember to subscribe. Thank you very much.